Dear students, following question is a 2-mark question from topic of connections of steel structure, where a bracket type 2 connection is shown in which a load of 10 kilonewton is acting at eccentricity of 100 mm from centroid of the connection, and here it is asked that the maximum force to be resisted by a bolt would be. Now the bolt that is farthest from the centroid, it has to resist the maximum load in normal direction, and all the bolts will be sharing equal shearing force because of 10 kilonewton acting in downward direction. So here the moment that will be acting at centroid of the connection will be P into E, that is 10,000 mm, because yes, 10,000, not mm, 10,000 Newton, because 10 kilonewton force is given, so it is 10,000 Newton into 100 mm, that is 1 into 10 to the power 6 Newton mm, or 1 kilonewton meter. Now there are 4 bolts, so as already talked about, that vertical shear force will be 10 by 4, 2.5 kilonewton, and P normal, that is normal to the line joining centroid and the bolt, P normal will be given by moment into Ri, that is distance of that bolt from centroid, upon summation of R square. Now here all the bolts, they are equidistant from the centroid, that is bolt that is marked as 1, 2, 3, 4. All these bolts are equidistant from centroid, that is marked as dot C. So R square will be, R will be 30 square plus 40 square, that is 30 square plus 40 square will give us this hypotenuse. So R is 50 mm. Summation R square will be 50 square plus 50 square plus 50 square plus 50 square for 4 volts, that is 1 into 10 to the power 4 mm square. So Pn comes out as 1 into 10 to the power 6 into 50 upon 1 into 10 to the power 4, which comes out as 5,000 Newton or 5 kilonewton. Now these two forces PV and PN, they are acting at angle of 36 degree, which I obtained after calculating the angle X as tan inverse of 40 is to 30, that is perpendicular upon base. This angle between radius or line joining centroid with the bolt and PN, normal force, is 90 degree. So remaining angle will be 90 degree minus tan inverse 40 by 30. All calculations made in degrees. So angle comes out as 36 degree. Now if one force is acting like this, another force is acting like this, and angle between these two forces is 36 degree. This is PV, this is PN. We know magnitude of PV and PN individually. From knowledge of vectors, we can calculate the value of resultant, which will be given by PR as 25 square plus 2.5 square plus 5 square plus 2 P1 P2 cos theta, that is 2 into 2.5 into 5 cos 36 degree. That approximately comes out as 7.17 kilonewton, making D as the closest available choice. Hence D is the correct answer.